I want to add another rule of exponents here. I'm going to add this one here. If I have a product, like something times something, and I raise it to the nth power, I can distribute this n to both of those factors, x to the n, y to the n. So as an example, let's look here at number 18. Number 18 is quantity 4y squared. And what I've got here is a product, right? I've got a multiplication in here, and I'm raising it to a power. That's what I've got here. Like the x is the 4, the y is the y, the n is the 2. So you can distribute that power. So I can distribute the 2 through here, and that's going to give me 4 squared y squared. 4 squared, I know, that's 16y squared. Now be careful here. Here's what the rule says. It says if you have a product to a power, you can distribute the power, right? Something times something to a power, you can distribute the power. Be careful. This one does not work. It does not say this. X plus y to the n equals x to the n plus y to the n. This does not work, right? I'll put a big line through there. And just to emphasize that it doesn't work, I'm going to write it real big. Maybe, hopefully we'll remember this. So what it says is this, is that if you have an addition to some power, that is not equal to x to the n plus y to the n. If you have an addition, you cannot distribute that power. But if you have a multiplication, then you can. It works for multiplication, it does not work for addition. So just as a quick example here, if we had this, what if we had x plus 4 squared? That is not equal to x squared plus 4 squared, or not equal to x squared plus 16. Let's see if we can simplify each one of these separately. Now what I've got here is negative 5 squared cubed. So I'm raising something to a power. In fact, I'm raising negative 5 squared to a power. So what are we going to do here? Now in 19, let's see if we can simplify each one of these separately. So I think it might be a good idea if we actually write this one out so we can see what it's telling us. This means we have negative 5 squared, negative 5 squared, negative 5 squared, right? That negative 5 squared appears 3 times. Now, this square is applying to the 5, not the negative. I'm going to think of this as negative 1 times 5 squared, negative 1 times 5 squared, negative 1 times 5 squared. And now when I take this one, I've got negative 1 times negative 1 times negative 1, which is negative 1 times, now look at this, 5 squared times 5 squared times 5 squared. We've got a multiplication going on, right? Multiply. So what do you do with the exponents? When you multiply, right, here we are up here, if you multiply, you add the exponent. So it's going to be 5 to the 2 plus 2 plus 2. So I'm going to get negative 1 times 5 to the 6th, which is negative 5 to the 6th. Now look what happened from the beginning to the end. I've got a negative. The 2 does not apply to the negative. So I get negative 3 times. So I got 3 negatives. An odd number of negatives gives us a negative. And then I've got a power to a power, so I multiply the exponents. So I have 3 negatives giving me a negative, and then I got a power to a power, so I multiply. Now what about here in number 19? Let's actually write number 19 out, and I think I'm going to get a little bit more room here. So how about if I wrote negative 5 squared to the 4th? Okay, so I really have 4 of these now. So this is going to be negative 5 squared, negative 5 squared, negative 5 squared, negative 5 squared, right? That negative 5 squared appears 4 times. I got it 4 times. Now look what we have. Think like we did over in the first one. You got negative 1s out here. So negative times negative times negative times negative. All right, negative negative is positive, times negative again is negative, times negative again is positive. If you have an even number of negatives, that comes out positive. And then I've got 5 squared times 5 squared times 5 squared times 5 squared. So I'm looking at this, okay? 5 squared, 5 squared, 5 squared, 5 squared, which is 5 to the, now you're multiplying, so you add the exponents. So we're going to get 5 to the 2 plus 2 plus 2 plus 2. I get 5 to the 2 plus 2 plus 2 plus 2 is 8. Now look what we have. I've got, look back at the beginning. I've got 4 negatives, right? The 2 does not apply to the negative. I got 4 negatives being multiplied. An even number of negatives being multiplied gives you a positive. And then I've got a power to a power, so I multiply the exponents. Now, let's do one more here. Let's look at this third one here. It's negative 5 squared to the 7th. I'm not going to write the whole thing out this time. I know how to do this. I've got 7 negatives being multiplied. An odd number of negatives being multiplied is going to give us a negative. And then I've got 5. Look what we have here. I've got a power raised to a power. So over here, I've got a power raised to a power. And so what do? You multiply, right? If you're looking at a power, right below it is multiplication. So I'm going to multiply those exponents. So this is going to be 2 times 7, and I get negative 5 to the 14. Number 20, up here at the top, we've got 8 times xy cubed. Right? So I've got something being cubed, and what's inside here is a product. So that's this rule right here. If I have something like a product raised to some power, I can distribute that power to each one of those factors. And remember down here we did this? If it's a plus or a minus in here, you can't distribute. But if it's multiplication or division, as it turns out, you can. That's what we have up here. I got a multiplication, so I can distribute that 3. So we are going to have x to the 8 times x cubed, y cubed, and that one's done. Now here in 21, we have a division raised to a power. Now, I'm going to say this is going to be similar to this. Over here, I've got a multiplication raised to a power, and you can distribute. Now we have a division raised to a power. So I really could add another one of these here. We could say this one, if you have x over y to the nth power, you get x to the n over y to the n. So if you have a multiplication to a power, you can distribute the power. If you have a division to a power, you can distribute the power. So back up here in 21, in both of these, you see we have divisions to a power. So I'm going to distribute that power all the way through. So we'll get 4 to the 6th over 5 to the 6th. And over here we'll get x to the 5th over y to the 5th. So now we've got 7/9 to the 6th, and then times 7/9 squared. So because I have two powers with the same base, I can just add the exponents, right? I'm multiplying. Both the bases are the same. They happen to be fractions, but that's okay. Both the bases are the same. So I can just write that base, 7/9, and then I'll add those exponents. You could probably do that one in your head, except 6 plus 2. Now I get the 8. And now I've got a fraction raised to a power, so I could leave it like this, or I could distribute that power to each one of those numbers. I'll get 7 to the 8th over 9 to the 8th. Now, here's another way we could have done this. Look at this one here. And just this one here. I've got a fraction to a power. I could have a division. I could have distributed that power first. Now, if I do that, it would look like this. 7 to the 6th over 9 to the 6th times. Now, I can do the same thing here. I've got a division. I can distribute that 2 throughout, so I would get 7 squared over 9 squared. And now, look at this top. 7 to the 6th times 7 squared. Two powers with the same base. You just add the exponents. So now I end up with 7 to the 6th plus 2 over 9 to the 6th plus 2. And I end up with 7 to the 8th over 9 to the 8th, which is the same thing we got over here. A couple ways to do that one. And that's often the case. There's more than one way to work through these problems. Problem 23, let's simplify this one here. I've got a division raised to a power, so I can distribute that power. So I'm going to get 7 to the 6th over 9 to the 6th times, now you know, this 7 squared, I could write that as a fraction, make everything fractions. If I got a fraction here, maybe I want that to be a fraction. I can write it as 7 squared all over 1. And now this top, I got a multiplication, right? Same base, 7. So I'm going to add the exponents. So I'm going to get 7 to the 6th plus 2 over 9 to the 6th times 1. The numerator is 7 to the 8th, and the bottom is 9 to the 6th times 1 is just 9 to the 6th.